So we're going to get right into the concepts of how to draw Lewis structures. So Lewis structures are basically skeletal structures of molecules that displays the atoms as well as the bonding and non-bonding and the lone pairs of electrons that surround those atoms. So we're going to draw the structure for carbon tetrachloride. Right? So the first step when drawing Lewis structures is to count the total amount of valence electrons of that molecule, and that involves counting the total amount of valence electrons of each atom as well as the total amount of that atom times the valence electrons. Okay, let me show you what I mean. So carbon has 4 valence electrons. It's a group 6 element, right? And chlorine has 7 valence electrons. It's a group 17 element, a halogen. And as you can see, there are 4 atoms of chlorine that make up the carbon tetrachloride molecule. So you have to multiply the amount of valence electrons of a single chlorine atom by 4 to get the total amount of valence electrons. So 4 times 7 gives you 28. And 28 plus 4 gives you 32 in total for the valence electrons of the carbon tetrachloride molecule. Right? So we're going to put this number right here, 32 electrons, so we can figure out the total amount of electrons the Lewis structure model is supposed to have when you draw it. So now we get right into creating a rough sketch of the Lewis structure model. How do we do this? Well, we have to figure out which atom would be the central atom. The central atom is usually the one that creates the most bonds. Carbon needs 4 additional electrons on its valence electrons to create an octet, while chlorine needs 1 additional electron to fill its valence shell to create an octet. So the atom that can create the most bonds is obviously carbon. Carbon, as we all know, creates 4 bonds, and there are 4 atoms of chlorine. So let's create a rough structure of the Lewis model for this molecule. So this is the carbon central atom. And these are the chlorine atoms surrounding that central atom. When drawing a Lewis structure model, ensure to put all pairs of electrons around the atoms, including non-bonding pairs and lone pairs. Well, my electrons may look a bit wonky, but because of the pen I'm using. So as you can see, each chlorine atom has 6 electrons surrounding it. The reason why there are only 6 electrons surrounding each chlorine atom is because 1 electron is participating in the bonding process between carbon. Each bond line represents 2 electrons. So whenever you see a single bond line, that is equivalent of 2 electrons participating in the bonding process. This Lewis structure model is covalent because there are sharing of electrons. Whenever we're drawing Lewis structures and we're trying to figure out if the structure is the correct one, we should count the total amount of electrons. This includes bonding and non-bonding pairs, as well as lone pairs of electrons, to see if it matches with the total amount of electrons that we calculated before, which would be 32. So, in counting all the electrons surrounding each chlorine atom, it would be 6 times 4, which would be 24. So we're going to put 24 over here. as well as the bonding pairs of electrons. So 2, 4, 6, 8, which is 8. And we're going to add these up. When we do that, we get 32 electrons. So this model is fine. So this is the carbon tetrachloride Lewis structure model. Right? So I'm going to do another one. Okay, so we're going to do a Lewis structure model for NH3. As I said before, whenever you join Lewis structures, the first thing you're supposed to do is to count the total amount of valence electrons of that molecule. So nitrogen being a group 7, nitrogen being the 7th element in the periodic table is going to have 5 valence electrons. And hydrogen being the first element in the periodic table is going to have 1 valence electron. But as we said before, whenever you're doing this counting process, you should also take into account the total number of atoms that make up the molecule. So as you can see, there are 3 hydrogen atoms that make up this molecule. So you have to multiply the total amount of valence electrons for one atom by 3. And that will give you a total amount of 8. So this molecule has 8 valence electrons. So we're going to do the rough work of the skeletal structure of the Lewis model. So we're going to try and figure out which atom would be the central atom. And as I said before, the atom that creates the most bonds is usually the one that is a central atom. Nitrogen has 5 valence electrons, which means that it only needs 3 more electrons to fill its octet. And hydrogen, being the first element in the periodic table, he has 1 valence electron and it only needs 1 more to fill its first shell. Its one and only shell. Okay, so let's get right into it. And remember, when drawing Lewis structures, you should always ensure that you draw the atoms as far away from each other as possible. When counting the total amount of electrons in the rough work of the Lewis structure, ensure to count the bonding pairs as well. As you see, there are no non-bonding pairs because hydrogen only has 1 electron to contribute to the bonding process. So the total amount of electrons for this structure is 6. If you subtract 6 from 8, you're only going to have 2 electrons remaining, which means that this structure is 2 electrons short. In this instance, you're going to use those 2 electrons and add them to the central atom as lone pairs. And this is the complete structure of the ammonium molecule.